Hello everyone, this is Naveen Teja Paravada from East Texas A&M University, and my CVT is 5032623. Now I'm going to explain you my project which I have been done in the automata theory as a course. So my CVT is 5032623, which ends with an odd number, so we need to make a project regarding the travel management application. So my project is regarding the travel management application, and in a brief, let me explain you what travel management application is. So a travel management application is where user can ask questions, and it needs to answer it back. So this type of application will be used in tourism as a vendor and as a user as well. So in this project, I'll be considering myself as the user for the travel management application, and where I'm interested in going for a tour or a trip. So I would be planning and asking some questions. So in this application, user can ask some questions. So typically, I have created 18 questions, where 15 questions are valid questions, valid sentences, and 3 are invalid sentences, which will be used to interact with the application. Taking the sentences into consideration, we will be creating context-free grammar, which is also known as CFG as an input, and this CFG will be converted to CNF, Chomsky normal form. And once it has been converted, we should be parsing to CKY, and also we'll be creating some tables of CKY tables. The CKY parsing algorithm in this project for the travel management application parses each sentence and verifies whether it is a valid or invalid sentences. So since we have spoken that I have created 18 sentences, so this 15 sentences are valid sentence and 3 are invalid sentences. So valid sentences like what do you prefer, flight or car? What can I get this itinerary? I want to check in. I like this river in Chicago. And these are all the set of valid sentences. And these are the 3 invalid sentences, which is like book a flight, give my ticket, and nothing. Now let us go to the CFG. So CFG is nothing but a context-free grammar, and these valid sentences and invalid sentences comes from CFG terminals from the set of code. We will be discussing more about the code in this project, um, in this video as well. So this project has been created using Python, and later in this video we'll be going through it. So once we have the set of terminals and we have a valid and invalid sentences, we will be converting it into the CFG. We will be converting these into the CFG manually. So once a CFG has been converted, it has to get converted to CNF. So what is a CFG? CFG is nothing but a context-free grammar which will illustrate the mechanism of phrases in various natural languages. These are created from smaller blocks in a natural manner, expressing the structure of sentences in a logical way. Because of its simplicity, the formalism is accessible in rigorous mathematical analysis. So these are the set of CFG which we have constructed. So before going further, we can discuss regarding the CFG text. So I have created a file on a CFG text where the terminals are nothing but a set of words, and then the variables are being derived from the productions. So productions is nothing but it is a set of CFGs which has been constructed using these terminals. So over here you can see S, CNP, nominal, VP, aux, det, noun, verb, pronoun, prepositions, etc. So these are all been variables that have been entered here. So and this so once we constructed the CFG will get converted into CNF. So how does it get converted? We have a set of rules like A tends to B, C, A tends to A, where A, B, C are non-terminals and A is a terminal, like smaller A is a terminal. So we have constructed a set of rules where the CFG can get converted to the CNF, and once the CNF has been converted, we will also be creating a file, like the output will be a file as well, which has a set of CNF converted CNFs. So once it has been converted, the CNFs will be list of, you can see, will be like this. So we have multiple CNFs created with the CFG. So once the CNF has been created, we can construct the CKY table as well. So in this project, we have created the CKY table for valid sentence and invalid sentences as well. So as you can see, the valid sentence over here has something as what do you prefer, flight or a car? So this what do you prefer, flight or a car is a valid sentence, which we will also be demonstrating it in this for a video. So as you can see, what has some s, ox and all, and as you can see, do everything. And also, can you search this flight has some s and it can all of it. So this is a valid sentences. So typically, if you can so yeah, let's check out with the invalid sentences. So invalid sentences are nothing but book of flights, which has a book and a flight, so there's a cap, and A has a determinant B, so it does it. And let us take another example. Give my tickets, give and ticket. These two aren't in a grammar. Since they aren't in a grammar, so it says that it's invalid sentence. So now going to the code, let us discuss regarding the code. So as I have previously mentioned, the CFG text is created manually by us. The terminals are a set of phrases and words related to the travel management application, and then the variables have been divided by productions terminals. So S, NP, nominal, VP, aux, and verb and noun, everything will be in this file. So now coming to the code, I have created this using Docker application. So I have created a container in Docker as with the Anaconda, and this Anaconda has a Python environment and Jupyter on it. So once we run that Docker, we should be able to see Jupyter in localhost 8888. So once you can see this Jupyter, you should be able to go to CYK Parsing. So in the CYK Parsing, I will be discussing about most of the functions which are which plays a major role in converting from CFG to CNF, and also creating CKY tables as well. So unit is nothing but it units the to list, and load model is once this CFG file has been loaded, and it is going to convert K for terminals, V for production, that is a variable scheme, and then P for productions. So and then once the model has been loaded, we need to clean up the alphabets and clean up with certain rules. So we have certain rules which will be cleaned up over here with a clean function, and then the alphabets for trimming and all will be cleaned up over here. So once it has been cleaned up, we can see that there is a pp print rules. So pp print rules is nothing but it prints the converted CNF from CFG, and then pretty form is used to output the grammar for a particular sentence. And then here you can see we have input some of the non-terminals as jar, and then we also have few eliminating rules with like non-unit until, where it eliminates the non-unitary rules and non-terminals, and also the non-unit, if there are two non-terminals, then also it's going to get terminal deleted. And the CYK parsing is the main function which is being used in this project. So the CYK parsing loads the model. Once the model has been loaded, it is going to send uh, model details to CYK parsing with the rules, and the CYK parsing will convert it the CFG to CFG to CNF, and then it will tell us whether the sentence is valid or not. So if the sentence is valid, it's gonna say yes. If not, then it's gonna say no. So from here, it is the main function, how it works. And model part is where our file is. So we have created the CFG file, and then from the CSV file, we have exported the K and rules, which is nothing but production variables and uh, terminals, variable and productions. And then the data is going to clean up, and once it has been cleaned up, it has been converted to CNF grammar for that particular sentence. So once it has been converted, we have outputted a file as out.txt, where you can see all the grammar. Oh, so now let us run. So as you can see, we have for history. So let us take one valid sentence. So let us try with what do you prefer, flight or car? What do you prefer, flight or car? Oh, sorry, that's a spelling mistake. Okay, so here it is. Now since it is a valid sentences, it says yes. So let us try with another valid sentences, like I want to chicken. So this is another valid sentences, so it says yes. So now let us check out with invalid sentence, like book or flight. So since this has been invalid sentence, it says no. Similarly, let us try with another invalid sentence, give my ticket. So it says no. And so if you can come out and go to OUT text, so this is the grammar which has been created for that particular sentence. So in our document, if you can scroll more down, you should be able to see all the output of each sentences. As you can see here, this is a valid sentence, so it says yes. Can you search this flight, which is S. And as you can see, we have tried this, I want to check, and it showed us yes. So similarly, if it's an invalid sentence, it's gonna output as no. That's Thanks for watching this video. I hope you like my project. Thank you.